Okay, this video we're going to be looking at factoring by grouping, and it happens exactly as the name suggests. And so I've got some examples here. Here's 4 examples, and the answers are given in red. So hopefully we're going to be able to get the answers in red. So if I look at number 1, when you have 4 terms like this here, I'm going to group the first 2 together, and then I'm going to group the second 2 together. Okay, and so with the first 2, I might write them out here, and then have a little bit of space in there. So with the first pairing there, they have an m squared in common, so I'm going to factor it out. Now what are you left with after you factor the m squared out? Well, if you were to go back and divide each term by m squared, then what would be left is what goes inside those parentheses. So m cubed divided by m squared is just m, and then we'll have minus, and m squared over m squared is 1. And then here, when I look at these this next pairing of terms, they have a 2 in common. And so that's what I'm going to factor out. And then, of course, what you'd be left with inside those parentheses is what you would get if you divide both terms by what you factored out. Okay, now if we look here, they have an m minus 1 in common. And then what's going to go in here? Well, whatever we've got out the front there. So m squared plus 2. And that's our answer, and we can see that that matches what's in red. So far so good. Okay, let's go on to the second one, and again I'm going to write this one underneath, and I'll leave a little bit of a gap. Okay, so with the first pairing you can see that the numbers have a 5 in common, and the lettering, the n's, have an n squared in common. So I'm going to factor out a 5n squared. So what's left to go inside the parentheses? Well, if you were to divide each term by what you factored out, what would be left over? And so the 5's will cancel here, and n cubed divided by n squared is just an n. Then we have minus. 10 divided by 5 is 2, and the n squareds cancel each other out. And then with the next pairing we have a 3 in common, so I'm going to factor that out, and then what I get inside the parentheses is what would be left if you divided each of those terms by what you factored out. And so we do have an n minus 2 in common. And then what's left? What goes inside these parentheses? Well, whatever's out there. So that's our answer, and you can see it matches the correct answer in red. All right, so let's just keep going. I'll rewrite this one down here, and I'll leave a bit of a gap between the first 2 terms and the second 2 terms. Okay. All right. With the numbers in the first 2 terms, they have a 5 in common, and with the lettering they have an x in common. So that's what I'm going to factor out from the first 2 terms. And what are we left with? Well, what you're left with to go inside those parentheses is if you divide each term by what you factored out. So 35 divided by 5 is 7. And then the x's cancel, and then I'll be left with a y. So I'll get a 7y for that first term, then minus, and the 5x's cancels completely, and so I have that. Okay. Now, this is really important. This is where this third one is different from the previous 2 that we just did. Our leading term there, the first term there, has a negative sign in front. So we are going to be factoring out a negative number. Now forget about the negative number. Just what do 56 and 8 have in common? Well, 56 is 8 times 7. So with 56 and 8, I'll factor out an 8, but because the leading term, the one in the front, is a negative, I'm going to factor out a negative 8. Then what goes inside these parentheses? Well, again, if I divide each term by negative 8, then that's what we will get. So the negative signs cancel here, and 56 divided by 8 is 7, and then we have a y left over. And then plus 8 divided by negative 8, the 8's cancel, but we only have one negative sign there, so you're going to get minus 1. So we do have a factor in common. It's 7y minus 1. And what's left in here? What's left to go in there? Well, whatever we have on the outside, so 5x minus 8. So this is my answer to that one. And you can see it matches the correct answer in red. Okay, so we're down to the last one, number 4. And so the numbers are getting quite big. And I might show you a trick where you can get the factors of that pretty quickly. So for this trick, I am going to use a calculator. So let me get all of my calculations back there. So with number 4, let me just draw a separation line here so I can do my work. Okay. Okay, so I'm going to rewrite number 4 down here. And I'm going to group the first two terms together, then leave a little bit of space and group the second two terms together. Okay, now the numbers in the first 3 examples were small enough to where you could see easily enough, you would know what the factors are and what they had in common. But if I look at a 224 and a 56, I might not know straight off the bat what they have in common. And so I'm going to show you with a TI-84 Plus how you can do that. Okay, so if you're on the main view screen for a TI-84 Plus, then press the Y equals button. And then if I want to see the factors of 224, because there's not a magic button where you can just put 224 and then magically get all the factors, but there is a way that's pretty close and pretty quick. So I press the Y equals button, and then for that first function, I'm going to define the number 224 divided by x. Now, I'm not going to look at the graph, but I want to look at points on the graph. So I'm going to press the second key and then the graph key. So the second key and the graph key. Now, I'm just going to concern myself with positive numbers. And you can see here where it's highlighted, the point 1, 224 is on the graph. But that's a pair of factors for 224, 1 times 224. And whenever you have your pairings are both integers, they're actually giving you factors of 224. So here we go, 2 times 112, that gives you 224. So that is a factor. Now, 3 is not a factor of 224 because it's paired with a number that's not an integer. But come here. 4 and 56 are factors of 224, 4 times 56, and I'm going to stop there because that's what I'm interested in with this pairing. The numbers 224 and 56 will have a 56 in common. Now, what else do they have in common? If I look at the lettering, they have an A in common. So I'm going to factor out a 56A. So what's left that goes inside those parentheses? Well, each term you divide out what you factored. So to get what's left inside the parentheses there, I'm going to divide each term by 56A. So 224 divided by 56 is going to be equal to 4. Okay, and the A's cancel, and I'm left with a Z. And here I'll have plus, and 56 and 56, they cancel, the A's cancel, and I'm left with C. Okay, now with this next pairing, since the leading term, all right, the one it starts off with is a negative number, I'm going to be factoring out a negative number. Now let's just forget about the negative symbol. What do 84 and 21 have in common? And if you don't know instantly, then we can repeat this process. I'm going to press y equals. I'm going to come here and just clear that old one. Let me get rid of that arrow mark I made. Okay, now I want to see the factors of 84. So I'll do 84 divided by x. And then I'm going to press the second key and the graph key. So I could have 1 times 84. I could have 2 times 42. I could have 3 times 28. Or again, 4 is the magic one because 4 times 21 is equal to 84. And we can see that 84 and 21 will have a 21 in common. So I'm already taking out the negative sign. And then I'm going to take out a 21. Now with the lettering, y times z and y times c, they have a y in common. Okay. So what is going to go inside that set of parentheses? Well, again, if I go back and I divide each term by what I factored out, and I factored out a minus 21y here, then you can see that the negative signs cancel, and 84 divided by 21 is 4. The y's cancel, and I'm left with a z. Then with the next term, the negative signs cancel, and 21 and 21 cancel, and the y's cancel, and so I'm going to be left with a plus c. And that's nice because I have a 4z plus c in common. And then what's left over? Well, what's left over are going to be these terms that are on the outside, and they're going to go in that second set of parentheses. Okay. Now, you always want to make sure that you're finished. So like with this one, 5 and 8 didn't have anything in common. 5 and 3 in number 2 didn't have anything in common, but I do think that 56 and 21 have something in common. And again, if you can't see what it is, if those numbers excuse me, are just a little bit too big for you, let's do the procedure again. Press y equal, clear that out. Let's see what the factors of 56 are. So I'm going to do 56 divided by x, and then I'm going to do second graph, and then let's just come up here. 1 times 56, 2 times 28, okay, 3 times, 3 is not a factor because it's not paired with an integer, 4 and 14, keep going, 7 times 8. Now that's the one I want to use because 7 is also a factor of 21. So the most that 56 and 21 have in common is a 7. So I can factor that out. Of course, the letters have nothing in common there. So this one can be carried out in a further step. And what are you left with? Well, what do you get when you divide each term by 7? And 56 divided by 7 is 8. And of course, you have an a left over. Then minus 27 divided by 7 is minus 3, and we have a y. And so that will be the answer, and it matches the answer that they have written there in red. Okay. I hope that this helped you. I'm Dr. Sooze. Thanks for watching my video, and I'll see you on some of the other videos. So thanks a lot.